Okay? I want to ask you a question. Do I play games on my computer while we're having class? Then what do I expect from y'all if you're going to bring your laptops in? Not to be playing games and watching videos. If I catch you, if you're going to be disrespectful to me, then you're going to be disrespectful to the class, and you're going to cause all the class not to have laptops. I told my classes yesterday that. It's not y'all. It's not just y'all. And I'm going to tell the classes today that. I don't mind a tablet, because a tablet I can see, because you usually lay it down and I can see, but you know how comfortable a laptop can be. Y'all can get comfortable with those, and you can, and I just want to throw that out there, because I don't do it while we're teaching on my computer, so you shouldn't do it on yours. It's not just y'all. I say that to all my classes. All right, now, with that being said, we're going to start today, unless anybody has questions. Does anybody have questions on anything so far? I did put up the second day video, so anybody having questions about My Labs Plus, you should be able to watch that video and get your answers. Pretty much, I went over the test, I went over the homework, I went over the Ask My Instructor button, I went over all that, and I did it again yesterday for the Math 12409, or 120 section 29. So you've got 2 second days you can look at, and I pretty much say the same thing, but I might have said something different in one of them, so you might want to watch both of them if you want to, if you need to. All right. So nobody's got any questions. Everybody's good on My Labs Plus and classroom procedures, correct? All right. So with that being said, I'm going to drag my My Labs Plus over. And of course, it is not exactly the way I want it, and it's not moving because I hadn't got it all the way over there. Please work. Okay. Okay, does anybody have any idea what just happened? There. I don't know what happened. There we go. And we're going to go to the e-text. Now you're fixing to see how I pretty much do things whenever it's not math. Whenever it's not math, we just go over stuff. And the first 2 chapters, okay, do y'all see e-text on there anywhere? Oh, there it is. When it's definitions and stuff, I'm not an English teacher, so we just look at it and I tell you what is important and what is not. Is that fair? Because we're only talking about 20% of your test. So I'm not going to spend a lot of time on this. I'm going to go through and I'm going to, we're supposed to go through 1.1 to 1.4, right? You're supposed to have your outlines with you. Is that correct? Somebody look at your outline. And we're going to do this every day until everybody brings their outline, because that's the number 1 piece of paper. 1.5. Now what about chapter 2? 2.1 through 2.3? Okay, so 1.1 through 1.5. So here we're going to start chapter 1 today. So that means whatever I cover today, you're responsible for as far as the homework goes. Okay, so contents, they go chapter 1 and 1.1. Okay, we're going to start with the difference between statistics and parameters. First of all, the definition of uppercase statistics basically is right there, and I'll make it a little bit bigger for those of you at home. Let's see, I can do it this way. No, I thought that was, I'll just do it this way. Is that good enough for y'all at home? Hopefully. Y'all ain't gonna say anything, so.
It's fine.
Thank you, I appreciate it. All right, so statistics is the science of collecting, summarizing, analyzing, and interpreting data. Now write that down, and you need to highlight the uppercase statistics. If statistics has an uppercase S, that means the science. A lowercase statistic means variables used for the sample. Variables used for the sample. So you can write down two definitions right there that you will be tested on. Uppercase statistic, meaning the science of, or the mathematics of organizing, summarizing, analyzing, and interpreting data. Now, you don't have to write all that. You can just say collecting, organizing, summarizing, and interpreting data. And highlight the capital S, because capital S means the science. Now, not only is that a Hubert question, that is also a standardized test question. So if you take an employment test, if you take a placement test in the future, if you take a curriculum test or an employment test for Michelin, or that could be a test question. Uppercase statistics. Lowercase is variables used, in formulas for the sample. You'll see that here in just a minute, but it'll be all wordy, talking about all different things, and that's the easiest. Lowercase statistic is variables used for the sample, and that's usually regular alphabetic letters, A, B, C, D, E, F, G, X, S. Those are just usually normal letters. That being over to the right is driving me crazy, so I've got to bring that down a little bit. There we go. Now, what I do in chapter 1 and 2, I go through and pick out what I would test you on. Is that fair? If I go by a word and I don't say anything, then chances are it's not going to be on my test. I think that's fair, isn't it? Yeah, Hubert, I think that's fair. Thank you, class, for the interaction. I appreciate it. Okay, a population. Population is always your biggest population. It's always your biggest group. A good example of population and sample. Population, all students at Tri-County Tech. Sample, Anderson campus. Now, your whole goal in probability and statistics is to take the sample and predict the what? Population. Why do you want to use a sample to predict the population? Because of two things that are important to all of us. And what are those two things? Anybody want to take a guess at it? The two most important things in our adult livelihood.
Money.
Money and what?
Time.
Good job. How'd you know that? Not many people know that. Your parents did a good job. All right? Time and money. When you reach the adult world, when you reach your career, that's your two most precious things, time and money. And a lot of people say, well, I don't worship money. I didn't say worship money. I said important, because it runs everything. All right? Time and money runs every career, all right? So if you go into a research type profession like psychology or history, or if you go into anything that deals with statistics, whether it be in the past or whether it be predicting the future, then you're going to be using a lot of samples. Now, the question is whether your sample is good enough to predict and whether it's biased or not. That's the question. Okay? Then there's your lowercase statistic. Lowercase is a numerical summary of a sample, a variable used in a formula for the sample. And it's usually a letter in our alphabet. I didn't say Greek alphabet, I said our alphabet. And the two most popular are X bar, which means mean, and S, which is standard deviation. Everybody with me? So a statistic, lowercase, is a variable used in the sample, calculations for the sample. Make sure you know what descriptive versus inferential means. Descriptive. Oh, descriptive consists of organizing and summarizing data. Descriptive statistics describe data through numerical summaries, tables, and graphs. How about your test grades over the semester? That would be descriptive. Okay? What do you do at the end of the semester with your test grades? You add them up and divide them by what? How many test grades you got? And that tells you what your grade for the semester is. That's descriptive statistics. Inferential uses methods that take a result from a sample, extend it to the population, and measure the reliability of the result. That's what I was talking about a while ago. That's not, is that predict, okay, if you make an 89 in my course this semester, does that predict what you're going to make in history next semester? No. Okay? Descriptive cannot predict. Descriptive tells you what you have. Inferential is like, I'm an executive for Michelin and I pull out 500 tires on each plant in the Southeast, and I tell the gurus at the Crystal Palace up there on I-85 that next year we're going to have at least 20% defective tires based on what I pulled from the Southeast plants. That's inferential. Everything that I just went over is a test question, possible test question. And they're all standardized test questions. A parameter is used in a population. A parameter is the variable used in a population formula. So what's the opposite of parameter? Lowercase statistic. Statistic, lowercase, sample. Parameter, population. What am I associating there? The first letter of each word. Population, parameter. Statistic, lowercase, sample. What letters, some of you probability and statistics people in high school, what letters do we use for a parameter? Not the alphabet, but what alphabet? Starts with a G. Greek alphabet. So you need to write that down so you know the difference between the two. Now, why do you need to know that? Well, so you don't show your ignorance in a meeting. What? Well, if you're not going into research, you need to know the difference between a population parameter and a sample statistic. If you're in a meeting and they throw up X bar is equal to 28 years old and mu is equal to 36 years old. Well, since you've been through this class, you know that mu is the population average. And you know that X bar is the sample average. And therefore, you won't raise your hand and say, what's the difference between X bar and mu? Well, you won't know mu anyway if you don't know what it stands for. I doubt you'll know what it is. But what's the difference between those two symbols? You won't raise your hand and say that. Now, if you're in a research, if you're going into research with your master's or doctorate, or if you're going into a field, then you got to get used to the Greek letters. Lambda, phi, and all them different theta. Theta is most noticeable trig. But you've got to get used to them. All right? Like I say, this is pretty boring, but that's why I don't teach English and history, because I don't like going through terminology and I don't like it. So, but I have to cover it, and this is the best way to cover it, to tell you what's important and what's not. Qualitative and quantitative. What's the old saying about quality and quantity? You want quality, not what? Quantity. Think about it. Think of something that you buy at a store. Okay, let's say, why do people go crazy over a certain brand of whatever? Because it's well put together and it lasts a long time. Yes? Okay, that's quality, not quantity. Okay, quantity is putting them out left and right, and you know, the ends not matching up, or a bolt not being, or a screw not being put in correctly. That's not quality, that's quantity. Okay, write it down. Qualitative is classification by characteristic, CC. Classification by characteristic. Blondes, brunettes, and what? Redheads. Brown eyes, green eyes, and blue eyes. Of course, we all know that people with brown eyes are a whole lot better off. Just like the redheads, right? Quantitative. How much everybody weighs? What's your age? What's the average age? If I go through and do a graph of everybody's ages in the classroom, that's qualitative data. I'm sorry, quantitative. Quantity. That means it has a mathematical what? Meaning. Blondes, brunettes, and redheads. Always remember this. Somebody give me the average of blondes, brunettes, and redheads. What's the average? You can't give me an average because it's not quantitative. Capiche? Yeah, we understand, Hubert. Good. Thank you for the interaction. Y'all suck. Discrete and continuous. Discrete. Put a word beside it that says concrete. Continuous, you can't predict. You can't tie it down. What the heck is he talking about? A discrete variable is something you can pin down. It's something you can predict. It's something you can blank. Starts with a C. Anybody want to know what that C is? Count. Count is the word you need to highlight. So get those highlighters out. And this one is very important because I'm going to put a question on the test on discrete and continuous, and half of y'all are going to miss it. Okay? Because I don't know why, y'all miss it. What is a discrete what is discrete in real life? Eggs. What do you mean eggs? Well, what do you do with eggs? You count them. You don't weigh them, do you? You count them. What about cars? You count cars. If you work for the traffic division, you don't weigh each car that passes you by. You count cars. Cars in the parking lot, that would be discrete. I'll give you another. What about 1/2? Is 1/2 discrete? Yes. because 1/2 is 0.5 versus the square root of 2. What is the square root of 2? Well, the square root of 2 is a bunch of numbers that have no pattern. They're irrational. Okay? Rational is discrete. Irrational is continuous. So what's the one word that you would use for discrete? Count. What's the one word that you would use for continuous? Starts with an M. Measure. Anything that you measure. Why? Well, let's say I go out, okay, y'all see those, okay, y'all can't see the parking lot, but just imagine this. There's some orange traffic cones in the parking lot. Everybody with me? If I gave you a box, if I come in here with a cardboard box full of measuring tools, you know those carpenter rulers that you unfold made out of wood, and a carpenter's ruler that you pull out, and a yardstick, and a roll of, a distance 50-foot roll, and I gave you your choice of measuring those orange cones out there. Would everybody get the same measurement? Hell to the no. Because half of you don't even know how to read a ruler, okay? And that's sad, but it's true. Half of you would go out there, and let's say it would be 3 foot, 3/8 of an inch. You wouldn't know what 3/8 of an inch is, so you would just say 3 foot. So half of you would just say 3 foot. And then 2 or 3 of you would go out there and go, okay, well, it's 3, and it looks like 7/16. 2 or 3 of you would say 3 7/16. And then 2 or 3 of y'all would go, I don't know what these little lines, but there's a 1 right there, so it's going to be 3 foot 1 inches. Everybody see what I'm getting at? What about something that's produced and put in a bottle, like liquor or milk, or these bottles of water? If you poured that water into a magical chemistry beacon, or what do you call them things, beaker, okay, that digitally told you how much was in it to the 1,000th of a liter, would that bottle be the same as another bottle the same size?
No.
No, it wouldn't. Because anything measured, let's write down what's measured. Length, volume, area, what else? Distance. I said length, I'm sorry. Distance. Think of meters, liters, and grams. What does meters measure? Distance. What does liters measure? Volume. What does grams measure? Weight. If you think of those 3 things, then you won't have a problem with the test question. If you start thinking, okay, somebody tell me the height of that tree out there in the parking lot. Is that continuous or is that discrete? Continuous, because no matter who measures it, you're going to have a different outcome. Versus, if I go out there and I lock the gate and I tell you to count the number of cars in this front parking lot, all of you would get the same number. If I just portion off this parking lot right here. Unless you can't count, all of you would get the same number. So that's the difference between discrete and continuous. As y'all noticed, I don't really cover the book. I just have my own little definitions, and it usually works out a whole lot better. Because if you understand the concept, then the words will fall into place. Do you see what I'm saying? If I give you a good example, then the words, no matter what book you read, will fall into place. To me, an example is a whole lot better than a bunch of words strung together by a Philadelphia lawyer. Okay? Which most of the time you can't understand. Oh, let me give you some examples of a number that could be considered qualitative or quantitative, but it's qualitative. Give you 3 good examples that are qualitative numbers. Social Security number, zip code, and area code. Why do those numbers, even though they're numbers, why are they not quantitative? Easy. Give me the average zip code. Give me the average Social Security number. They have no what? They have no mathematical meaning. They are identifier. Identify, that's equal qualitative. Numerical, that's equal quantitative. So I just thought I'd show you that because sometimes people get kind of confused when they see a Social Security number on a test. Social Security number is just like blonde brunettes and redheads. Brown eyes, green eyes, blue eyes. It's an identifier. Hopefully we feel good about ourselves. Go ahead and write this down, and I want you to write this down for standardized tests, okay? Because you might see this on a standardized test. I don't test you on it, but nominal, which is the umbrella. Nominal is pretty much any type of measurement. It's the catch-all. Ordinal means any data that's in what? What's the first 2 syllables or first ord? What does ord mean? Order. So ordinal means any measurement in what? Order. Interval, 0 does not equal absence. Your birthday. If your birthday is 0, does that mean you don't exist? No. If your birthday is 0, that means you just have been born. Okay? Or whatever, 6 weeks, you know how they do 6 weeks old, 18 weeks old, 13 months old, you know what I'm saying? Your birthday, your age, I'm sorry, your age, not your birthday, your age. If you're 0 years old, does that mean that you're non-existent? No. A ratio, oral ratio. Ratio environment is properties of intervals where 0 does mean the absence of quantity, such as temperature. And they'll give you some examples probably on the next page. I think they do. Yeah, there we go. So write those down if you want to. Gender, well, that would be nominal because nominal covers everything. If I tell you to go outside and count those cones, that's nominal. If I tell you to go outside and measure, you know, those trees, that's nominal. But if I tell you to put the color of cars, count the color of cars, that would be ordinal because you have some kind of order. The color of cars would be your order. Letter grade earned in your statistics class. That would be ordinal. These are good, like I said, these are good standardized test questions. So that's why I include them. Even though I don't test on these, it's going to be a homework question, but you need to have it in your notebook just in case, you know, if you're smart and if you're fixing to take a placement test or a employment test or a nursing test like the TEAS test, I believe I would go over some math before I took the test. And this is one thing that you need to remember. How we doing, teamers? Y'all okay out there?
Mm-hmm.
Good. All right, we got 1, 2, 3, 4. I didn't see those 4. 4. So we've got 9. How many we got in here? 7. So everybody's here today. Everybody's doing good. And that's 1.1. So right now, you're responsible for 1.1 material. So the next time we meet, what should I have in my 120 folder? Any questions that you don't what? Understand? Send them to me, ask my instructor. After I start 1.2, then you'll be responsible for 1.2. So when we meet again, I'm expecting questions from those homeworks. And if I don't get questions, what am I going to assume? You understand it? And I'm going on to 1.3 or 1.4. And that's the way I teach. There's 1.2, observational versus experiment. And that is a big test question. And I'm fixing to, where is it? They're supposed to have it in colors, but here, why not? Let me see if they have it on the next page. There we go. An observational study. Dang old looking at people. Dang old perving. Stalking. Remember stalker, okay? Because all you do is what? You just sit behind a mirrored glass and you what? You watch people. A good example would be sleep apnea patients. What do? They put them in a room with a bed, put them to sleep, not put them to sleep, but let them go to sleep, and what do? They video them. Some of y'all might have seen them when they're green, they're the night vision, and they flip and turn. Some people sit up straight in the bed. I don't know if some of you have seen those videos before, but they're kind of funny because you see people with actual sleeping disorders. Okay? That's an observation. What if, whenever a person moved, I was to shock them with 120 volts of electricity? Well, then that observation becomes a what? What's the E word? Experiment. Experiment is when you interject something into an observation. Simple as that. If I watch people in the parking lot and I just watch them all day, that's observation. But what if I was to put a $20 bill out there and super glue it to the sidewalk? That's an experiment. It's very simple, and there's not really much meaning there, but the whole point is that there is a difference in the observation. Okay, so that's the two differences. Observation, you basically observe, and experiment, there is something interjected. Now I want to go back to something on the back of this page. Right here. In research, we wish to determine how the varying amount of an explanatory variable affects the value of the response. Write down explanatory and response. This is one of those things that they test you on and they put in the homework, but you don't catch it because they don't put it in a colored box. Okay? Explanatory is your independent variable. For instance, gas mileage on a car. Okay, if you don't have gas, you don't have what? Gas mileage. So you've got to have gas in a car to measure the what? The gas mileage. So gas, how many gallons of gas you put in a car would be your explanatory. Gas mileage would be your response. X value, explanatory. what would be your response? Your Y value. Input, output. Now you need to write those associative words there so you can remember what the explanatory is. And explanatory has what letter in it? X. Remember that, because that will help you figure out on a test what they're asking. Response variable, Y. And I always have to cover that because that question is sent to me every semester in the homework, because what happens is, since they don't have it in a box with color, students don't go over it. And they don't go over it, and then when they get to the homework, they don't know what it's talking about.
Did you say the dependent variable was gas?
Yeah, for gas mileage. Because if you
Okay.
don't have gas, you can't measure the gas mileage of a car. Okay? Because the car won't move. Go ahead and write down confounding as a standardized test question. When the effects of two or more explanatory variables are not separated, therefore any relation may exist. That's why confounding can be a major problem with observational, as not as big a deal with experimental. Because with experimental, if I shock you every time you move, what are you going to quit doing? You're going to quit moving. You see what I'm saying? So there's a response there. And I use the shock because that's, if you think about that, then it makes sense. Confounding is when you have two or more things that, and you can't separate the two. So hopefully they'll give you an example. They should. No, I don't. A lurking variable. Lurking, meaning behind the bushes. What does that mean? A variable that is not considered. Let me give you an example. Let's say that a study is done and they have found out that the number of drownings increase at the same rate as the number of deaths by Rocky Mountain spotted fever. What if I told you that? What would you say? What would be your conclusion if I told you that the death rate of drowning is about the same rate as, or increases at the same rate as the death of Rocky Mountain spotted fever? Say again?
You're more prone.
No, not that's a good answer, but no, they're talking about general population, just the numbers of deaths. So, what does the two have in common? Anybody tell me what drowning and Rocky Mountain spotted fever have in common?
The temperature?
Good job. How did you know that? You must have read the book. You must have read. I'm not used to students actually reading. Okay? Temperature. What the world temperature? Temperature is a lurking variable. Think about it. Is the increase in death by both going to be in December or going to be in June, July, and August? June, July, and August, because everybody does what in June, July, and August? They go outside. So that's a good example of a lurking variable. The lurking variable in this scenario is temperature, or you could say season, or whatever. Okay? Did you read that out of the book? You had to. Or you just smart, right? I'm kidding. Let's look at the time because I don't want anybody going into convulsions. Okay, 8:55. Let's say this class ended at 8:55, right?
Yes, sir.
I thought so. A confounding variable is, I thought we've already went over confounding, whose effect cannot be distinguished from a second explanatory. We already talked about that. I'm looking for anything else. Make sure you write down cross-sectional. That's where you look at several different several different samples. That's cross-sectional. You don't have to write down no more than that. You just need to know the difference between cross-sectional and a retro, which I'm looking for retro right now. Maybe it's on the next page. There's retro. Case control. Retro, what does retro mean in our society today? I'm sorry, what? Old, meaning in the what? In the past. So a retro would be the suicide rates for people in 1972. That would be retro. Versus the suicide rates now of college students, high school students, and old people. And that would be cross-sectional because you're looking at three different what? Samples. Okay, I'm going to try to finish up. I don't know how much is in 1.2, but I'm going to try to finish up. I don't know. We may be in, let's see. Census. Make sure you know what a census is. Everybody should be doing that now. It's every what? Every 10 years. Century. Or every, I don't know why it's called census because it's every 10 years. I don't know. Century is every 100 years. Okay, I'm not going to worry about it. Census is measuring data every 10 years, which is very important for a country. That's it, 1.2, good stopping point. So what I'm going to do now is I'm going to stop the recording, stop the presentation, and make sure